Why hello everyone, Gameboy here, and I am going to be kind of showing off this game, if you would call it a game. It's called A Slower Speed of Light, and it's developed by MIT Labs, and it's for free. I'll put a link in the description so you can download it. Now essentially this game is a concept. What if you could reduce the limit of speed of light? Just make it so you're closer, you can actually achieve it. Not actually achieve it, because theoretically it's impossible at this moment in our history to actually go faster than the speed of light, but you could get pretty goddamn close with the right technology. Once upon a time, in a quiet village, there was a little child. Sadly, the little child fell into death's icy grip far too soon. The little child's spirit began the journey to become one with light. But the speed of light was too fast for the small and clumsy little spirit. Luckily, the spirit world is full of magic orbs that slow down light. Collect orbs to slow down light on walking speed, so you can finally move on. As light gets slower, you'll be able to see beyond what humans can typically see. Alright, so there you go. It's the story, all that, it doesn't really matter. It's something just kind of throw in. It's all about the concept. Now, essentially what this game is trying to show is the speed of light is the speed that light moves, that photons move. It's the speed they move in. It's pretty self-explanatory, at least in that regard. Now we can see visible. This is what we can normally see. Now there's infrared and ultraviolet. Those are different wavelengths than we can normally see. Now if you walk, the faster you go, the more you'll be able to actually see this. Now, to actually see any of these effects, you have to be moving at an insane speed. But with these magical orbs, you could do that while not moving really that fast. So let's start collecting these. Now what is happening here is that I'm not actually moving faster, but the speed of light, the actual speed of it, is slowing down. Frame rate stripping a bit, that's weird. As you can see, when I stop moving, everything goes back to normal, but when I pick up, I move faster. Kind of. And you could start seeing those, you could actually start seeing heat without the use of technology. Like we have cameras that could see infrared, that could see ultraviolet, maybe. Can't remember on ultraviolet. But it's all about photon speed and light wavelength. Now, since I was moving real fast there myself, coupled with the slower speed of light, you could actually see what you normally would not be able to see. Now I'm halfway there. Now if you start noticing, the world itself is actually warping. It's a effect. I know the name of it, I just can't pronounce it. Essentially, the faster you move, the closer you move to the speed of light, time and space itself literally warps around you to keep up. Essentially, in a way, everyone in a very minuscule amount of time, everyone is living at a different point in time in a way. But very crazily microscopic in scale. Yeah. But essentially with this, time travel is actually, it's been proven. Just not in the way you might think. We cannot move back in time, at least theoretically we cannot move back in time. But moving forward in time and slowing down time is been proven. And that has been done on essentially the experiment, if I remember, is they had two watches synchronized to the dot. And one went on I think it was a Blackbird, I forget the actual call sign of the model of the plane, but it's essentially a very fast supersonic plane. And they had that go as fast as possible, and if I recall correctly, when they returned to each other, they were off sync. And there's been numerous other studies, but that's the only one that really stands out. I could be wrong on that one, but I don't know, that one just pops into mind. See, everything is, when I kept on moving, things are warping around me. When I move backwards, warp, seem to get bigger in a way. That's all time and space warping around you. Now, the faster I move, you can see all this light, all these wavelengths, all the photons that you would be impossible for a human to see. But due to the speed of light being slowed, I'm not actually moving faster, everything is kind of moving slower. There's only two left. Where the bollocks are they? I think they're over there? Yeah. So, as I've stated before, it is theoretically impossible for anything to go faster than the speed of light, let alone reach it. The speed of light is a barrier, if you will. Like the sound barrier. We broke that, but this one is a lot different. The art's interesting. Okay, so I clicked on the orbs. Now, they removed the color effects just to show this effect of time and space literally warping around you to keep up. So let me move back. So, time and space is, if I'm correct, is slowing down and trying to keep up. Now, when I go forward, it's actually increasing in time. Things are moving faster through time, and everything warp. Now let's see if I can get real fast before this thing ends up. Let's try to break that barrier. Wow, fuck. Yeah, it's quite trippy. And I just think I just broke it, but yeah. So there you go, there's the end. Now the second part of this video is I'm gonna actually there's a description of everything that's happening. It's very technical and I'm not the best reader, but if you like to stick around and actually figure out what the fuck just happened, well, stay tuned. If not, thanks for watching. Oh, okay, so my time, like I was explaining earlier on those watches, my time is actually 5 minutes and 16 seconds, while the world is actually 5 minutes and 38 seconds. I was moving slower than the world. Now, what happened? Make everything as simple as possible, but not simpler. Albert Einstein. In a slower speed of light, the speed of light slows down with every orb you pick up. It is impossible for you to reach the speed of light, but certain relativistic effects become more visible as you get very close. Yeah, I can't fucking pronounce that. Doppler effect. Light behaves like a wave, and different wavelengths appear as different colors. As you and other objects move around, the wavelengths of light changes, appearing redder or bluer to your eyes. Some light becomes infrared or ultraviolet, which your eyes cannot usually see, and other invisible sources of light becomes invisible. I see heat. Searchlight effect. Moving left, the objects on the left are brighter than the objects on the right. Light also behaves like a stream of particles called photons. When you run towards a stream of photons, more photons hit you and objects become brighter. This effect is known as relativity abbreviation. Special relativity. Light always moves at the same speed, so if the speed of light is constant, then the distance and time in the world around you have to warp. The time is different from the time in the world, time dillion, and your distance and difference of the distance are different than the distances in the world, the Lorentz transformation. You have to be much closer to the speed of light to notice more dramatic effects of the Lorentz transformation compared to the Doppler and searchlight effects. At the end of the game, the Doppler and searchlight effects are removed to make the Lorentz transformation easier for you to see. But how can time and space stretch? These seem so unreal. Science! The runtime effect. Normally light is extremely fast, but it takes time for photons to reach our eyes. When you look at anything, you're actually observing incoming light from some time in the past. The farther you look into space, the further you look into history. This is easily noticeable when you look at objects moving relative to yourself. Objects normally beyond your field of view can become visible when you move nearer the speed of light, as you see them as they were in the past. And you have the acknowledgements. Of course, Albert Einstein. But yeah, it's a lot of science. I love science. I love physics. And so when this came out and I heard about it, I was like, I gotta play this. It's great for learning. It's personally for me, visual, and I'm a kinesthetic learner, whatever you call that shit. I learn best by looking at it and messing around with it. And this is a great way to grasp the concept of the speed of light and all the properties that are associated with it. So thanks for watching. Till next time, guys.